whatever you want. And then you do the circle method. That's 2 to the x equals 16. And now it's like the problems we had on the last test. Take 16, break it down into 2's. Notice it breaks down into 4. So your answer is just 4. So yes, it was simplified. This is just 4.
So it's building kind of off the stuff we did yesterday.
Oh yeah.
Wait. What'd you do after 2x equals?
I broke down the 16 into 2's so they have the same base.
Mm-hmm.
And there were 4 2's here, so that's 2 to the 4th.
Yeah.
And then since the big numbers are the same, the little numbers have to be the same. So x is equal to 4.
Just because they're supposed to equal each other?
Oh, yeah, because of this equal sign right there. Yeah. Gotcha.
But I think I might be confused too.
Okay.
So you did, you did it like, I don't know, we can continue until I figure out how to ask the question.
Okay. So on the next ones, we do the same thing, only notice on these there's a number in front. So when you have a number times a log, we can rewrite it how?
Can you do it? Oh, you would just rewrite it as the exponent?
It is an x. Oh, yes, sorry. You're absolutely right, sorry. So yeah, if you have a number times a log, you can rewrite it right there as that exponent. I was thinking it was already an exponent. So that's log base 3 of x to the 1/3 and minus log base 3 of y squared. We okay with the 1/3 and the squared? Gracie, is it on there?
It's on there.
No, it's not.
I looked at it.
Oh, no, my phone. I
Yes. Yes.
So I get the, I get how we get log 16, and then I get how we do the circle method, and then you put the 2x. But what happens to log?
Well, when you rewrite it as an exponential, the log goes away. That's what we did yesterday. It's like that's what a log is. It's an exponential rewritten.
And then just once you always get to having the same base, if there's an x in the exponent, it's just going to be the same.
They're just equal to each other, the exponents are. Yeah. All right. So now we have 2 logs that are subtracted. So how would I rewrite those? Division. So it's log base 3 of x to the 1/3 divided by y squared. Can't really simplify this because I don't know what x and what y are. This is okay. Or you may see it like this. X to the 1/3 could be rewritten as the cubed root of x. It doesn't matter which way. Just like if it was multiple choice, though, I want you to be familiar with both.
Is log 3 and then the fraction out, is that one thing?
Yep, it's all together. Log is like an operation. It's like adding or subtracting or multiplying something you're doing to a number. Yes, ma'am. You may. Grab pass, let's go correct.
Okay.
Okay. All right, let's do 3. Okay, try this one. It's natural log, but it's done the same as log. Think about the properties, adding, subtracting. Just look at the first two things. There's two natural logs, a plus sign in between them. And use that property.
So do you always have to set? Do you always have to set ones like that equal to something before you do anything?
No, we did this one different because there were no variables. And it's all numbers.
Who has my numbers? This is all
Oh.
in math. Can you check this?
I don't remember what it answers. Well, it's good. It'll simplify, but yeah, that works.
Okay.
Yeah, except for you still have a natural log there.
If you, so you would have to break it up and do it first.
Yeah, I would just look at those first.
So you would just multiply that and add the other.
Yes.
Was that nice? Miss King,
Yes.
I have a question.
On your test?
You
Hang
just
on, I'll
said
give you
how.
a Well, that was my question. How?
I did write it.
Okay, I'll come look at it.
And I wrote the exact same thing I wrote the other one. It didn't count.
Shoot.
That's up for the word choice.
There's
Nothing else
a big difference between a
Actually-
transformation and a reflection.
It's relative.
It's like the gender
No, okay.
versus male.
No. Okay.
One's more specific,
But that's the thing, it's more specific.
right?
It's still correct though.
No, it's not correct enough because it isn't just because there were two
It's
transformations.
like a square and a rectangle.
Because you're saying then if it was moved to the left 3 and then moved up 2, it would be decay. No.
I put on here two reflections, move
Right.
one, move right, reflect the umbrella terms.
Miss King, I know.
Okay,
how
moving
to
on.
do it.
So you have natural log of two things added together. Two natural logs with a plus sign in between them. So I write that as one natural log, and what do I do with the things I'm taking the natural log of?
Multiply.
Multiply. So we would multiply x times x plus 2. Bless you, a whole bunch. So if you're multiplying, some of you went ahead and multiplied that out. Made it x squared plus 2x, which is fine. I'm not going to yet. Now we move to the next thing. We have a subtraction sign. What do we do when I have logs with the same base and they're subtracting? We divide. Very good. So we're going to divide what we're taking the natural logs of. So it becomes 1 natural log, and then x over x plus 2, or x times x plus 2, over x cubed. That will simplify. You have an x and an x cubed, which reduces to x squared. That'll become natural log of x plus 2 over x squared.
Oh my god, that's what I had.
I know you just left off the natural log thing.
That is not what I did.
But I erased it because Emma had a
That's
different
not what I
answer.
had because I with a 2x